Hello, trig class. It is our job tonight to learn the law of cosines. So it's 12/8/15. So this is Tuesday, and I'm gonna jot down the time so I don't blab too long. All right, that shouldn't take long, but I say that a lot. Let me see if I get some better lighting in here. It looks kind of blue, doesn't it? Hold on a sec. Alright, is that any better? I think it is. Alright. Alright, the law of cosines can be written like this. A squared, and we have a triangle, of course. It's a non-right triangle, and we have capital A, capital B, capital C, little c, little a. All right, as we have been trained to do. So with that, here is the law of cosines. It is A squared equals B squared plus C squared. Looking familiar? It's not going to be the Pythagorean theorem, but just for a memory aid, we have the A, B, and C pattern. There is an equal sign here and a plus sign. Then it is minus 2BC cosine A. All right, so let me show you some ways to remember that part. The minus part and the 2 part, there really isn't much I can say about that except to know it. And here, however, notice whatever values here and here, add it before they're squared. There is multiplied here, b times c. B squared plus c squared, and then bc. And whatever side is over here, the angle across from it is here. So let's see, with all those relationships, can you come up with the other version of the law of cosines? Because we can start with b squared here. Then we would have the other two sides, a squared plus c squared, minus 2. Remember how this pattern followed. AC cosine, and this always matches, so b. And there's one other form, and that is, see if you can get it. Oops, I see a boo-boo. Sorry about that. So hopefully you saw that. So these two are supposed to meet the pattern there. Alright, so there are 3 versions of this rule, all depending on what you know and what you don't know. I tend to not memorize any of them, but just the principle. One of the sides squared equals the sum of the other 2 sides, each squared, minus 2 times the product of those 2 sides that were originally summed, times the cosine of that other, of the angle across from the original side. So I see more of a pattern than I do a memorized formula. So let's go down here and do one. Let's give ourselves a triangle, and we can use this law of cosines when we do not have a pair. Remember, if we had a pair, we might as well just use the law of sines. So right here, I do not have a pair. I know 12 and 9. But 9, across from 9, I don't know this pair. Across from 12, I don't know this pair. Across from the angle 87 degrees, I do not know this pair. So there's no pair, so I have to use something other than the law of sines. And that's when we use the law of cosines. What we see here is, we know a side, an angle, and a side. So this is usually, this is key to remembering that whenever we have 2 sides and the angle in between, we end up using the law of cosines. So let's see. I'm going to start with the side opposite the one angle that I know. So I have a squared. So I'm going to use this version. Alright, when I do that, I just plug it in and solve it. That's an equal sign. I don't know if it's showing up well. Alright, so a squared is unknown. I'm going to look for that. B squared, C squared, minus 2 times cosine. The angle across from this was 87. Alright, so for that, basically I figure out this on the calculator, making sure you're in degrees, and you'll take the big square root of it. So when I do all that, I think I got a 225 from these two minus a 216 cosine 87. Now, one of the problems is forgetting the rules of order. Notice this and this may be added, but it cannot be added to this because this is held to this by multiplication. So I have to do my multiplication first, this whole thing, before I can combine it with that. Many students will take whatever this number is and go 12 squared plus 9 squared minus whatever this is. And that is disobeying the rules of operations. You must do multiplications before you do additions and subtractions. And dear Aunt Sally would roll over in her grave if you did that. So I can't take 225 and subtract 216 and continue. No, 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 no. Don't even think about it. All right. So as we go on from there, I think I took cosine of 87, multiplied it by 216, and subtracted that from 225 and took the square root. And when I did all that, I got 14.6, so you can check that. So I'm going to go over to my triangle here and put in A equals 14.6. Now, guess what? I have a pair. And guess how I'm going to finish this? Law of sines. So we're well taught in that. 14.6 sine of 87 equals, I'll do 12 over sine of b. And when I do that, cross multiplying and so forth, I ended up with sine of b equals 0.82. And that gave me a b of 55, about. So I put that up in the triangle, 55. I have this angle, this one, to get the top one. I can just do 180 minus 55 minus 87, and I get 38. Is there anything left? 38 degrees. Nope, that's it. So I was able to solve that triangle, first using the law of cosines, and then using the law of sines. I hope you found this informative. I'll show you another case, but I'm not going to do it because you probably don't get a whole lot out of watching me do it anyway. And say I have a triangle where I know all three sides. Suppose I have 50, 70, and 60. And I don't know any angles. So that would be a side, side, side situation. When I have that, it's all, there's no pairs. I don't know this side and the angle opposite or any others as well. So I have to use the law of cosines. So putting those numbers in, you'll see you can call any, that we usually call this A, B, and C. So you're going to put in 70 squared equals 50 squared plus 60 squared minus 2 times 50 times 60 cosine A. Then that will get you angle A. And when you do that, then you'll be ready to use the law of sines to continue. So without even doing it, I'm sure you could. So we will get our chance tomorrow, and this is short and sweet, so can't complain. All right, I'll see you tomorrow. Have a good evening. Bye.